Okay, now that you've graphed it, your calculator should be in radian mode. So I just want to show you again how to do it. So go to Menu, Settings, and make sure that everything is in radian mode. You can make it default. Okay. And when you graph sine of x to the third minus x, which is what was in our problem, you need to find the interval between 0 to 2. So you need to look between 0 and 2 and find where it's increasing. Well, increasing means for the derivative to be above the x-axis. Okay, as you can see on the calculator, your graph should look like this. I'm focusing between 0 to 2. And I want to see where the graph is above the x-axis. So what I did was I said, okay, it's going to be this little mountain over here that's above the x-axis. I need to find the beginning and ending of it. So I went to Menu, Analyze Graph, 0. And I found the first 0, which is 1. Then I did it again. Menu, Analyze Graph, 0. So I went and found the second point. So that means from 1, from 1 comma 0 until 1.69 comma 0 is where I'm positive. So that's where I'm increasing in my function. So I'm going to look for the answer 1 to 1.69 and find my closest value, which is B. The next problem says the derivative of the function is given by f prime of x equals x squared times cosine x squared. How many points of inflection does the graph of f have on the interval from -2 to 2? So I'm focusing between -2 and 2. And I need to get points of inflection. Let's recall that means where the second derivative changes from positive to negative or negative to positive. So what we have is the first derivative. We need to get the second derivative. Well, we can do that in our calculator. Okay, so let's go to our calculator. Since this is the calculator section, let's go to Calculate. I'm going to do Menu, Calculus, Derivative, and I'm taking the derivative with respect to x. I'm going to type the function in here. X to the second times trig cosine x to the second. So what I'm doing here is taking the derivative of x squared times cosine x squared. Enter. If we did it by hand, this is what we would get. 2x cosine x squared minus 2x to the third sine x squared. Okay, if you're going to do it by hand, this uses the product rule, which is f prime g plus f g prime. And the negative comes from cosine because the derivative of cosine is negative sine. Okay, so let me write down that derivative. The second derivative is 2x cosine x squared minus 2x to the third sine x squared. Let me just double check. Okay, so now we have the second derivative. Well, we need to find where it equals 0 and where it changes from positive to negative or negative to positive. Let's not make it hard on ourselves. This is the calculator section, so I'm going to graph this and see where it equals 0 and changes from positive to negative or negative to positive. And I'm focusing between -2 and 2. Let's go to my calculator. So one way I can do this is go to my problem, highlight my answer, copy it, go to Menu, go to Graph. Okay, so I'm going to graph our derivative. All right, now it looks crazy. Okay, it looks crazy. It should look crazy like this. We need to focus on what x values. That's right, negative 2 to 2. So focus between negative 2 to 2. Negative 2 to 2. Okay? I'm focusing between negative 2 and 2. Great. Now you find where it equals 0, meaning where it crosses the x-axis. So I see 1 right here, 2 right here, 3, 4, 5. There are 5 times that it crosses the x-axis. Now the other thing you have to check is, does it change from negative to positive or positive to negative in those zeros? Let's see. For the first one, yes, because it goes from negative to positive. The second one, yes, because it goes from positive to negative. Third one, yes, because it goes from negative to positive. Fourth one, yes, because it goes from positive to negative. Fifth one, yes, because it goes from negative to positive. Okay, so when I say negative, that's below the x-axis. Positive is above the x-axis. So it happens 5 times. 5 times. Okay, again, we found the second derivative. We graphed it. We saw where it equals 0. And we count how many times it changes from positive to negative or negative to positive. Those are how many inflection points you have. Okay, number 84. The graph of the derivative of a function is shown in the figure above. So this is the derivative. Before I even start, I'm going to go ahead and write above means increasing parts of the graph. Below means decreasing parts of the graph. Okay, so the graph of the derivative of a function f is shown in the figure above. The graph has horizontal tangent lines at x equals negative 1, x equals 1, and x equals 3. That means the second derivative there is 0, because it's the derivative of the derivative. The second derivative is 0. The second derivative is 0. Great. Which of the following values of x does f have a relative maximum?